Hello, good evening, everyone.
Hello, good evening.
Good evening, good evening. Just give me 1 second here, okay?
Sure.
There's two people that cannot make it to class today. They mentioned they had a shift change, so that's okay. No problem at all. 1 second. How's everyone's day today?
Pretty good.
Very good, very good, very good. Pretty good is very good,
Yeah.
The weather's getting better. It's a lot warmer today than yesterday. Are you guys all in so I'll get you guys to introduce yourself individually. I'll start off with whoever wants to go first. You guys can unmute yourself and talk. Tell us about yourself and your background and why you chose to move into IT rather than other fields.
Okay, I'll start. My name is Muhammad Aliuddin. Shortly, you can call me Ali. And I actually have a bachelor's in computer science.
Mhm.
And I chose this course because I wanted to get a foothold into getting into IT, because I haven't had a starter job yet. So it's mainly why I decided to go for this course.
Very good, very good. And are you in Ontario Valley or are you in somewhere else in Canada?
I'm in Surrey, in BC.
Sorry, BC. Very good, very good. Thank you so much. Thank you, Ali. Who wants to go next? I have Banu or Simran.
Sorry, my name is Diksha, but the system is of Bhanu, so that's why it's showing the
Oh,
name as.
okay, Diksha. That's why I thought I was like, okay, you know what? Some people have a different name, right? So then they're registered name, so that's okay.
Yeah.
Yes.
So, hi everyone, my name is Diksha. I'm currently residing in Brampton. I have my bachelor's in computer science and then master's in cybersecurity and computer forensic here from
Very
Lambton College in Mississauga.
good.
And then I went into immigration field. Um, Recently, I got my permanent residency, so I'm planning to switch towards IT. Seeing no growth financially in immigration firm, so I thought to pursue my further knowledge or upgrade my information in IT and achieve my goal of reaching to GRC analyst.
Mhm.
So that's what I am planning up to now.
Very nice. Very nice. Thank you so much. Okay, last on live I have is Simran. Hey, Simran, can you unmute yourself? Are you having any issues with your mic? Okay, so she can't. I think Simran's at work. That's the reason why. No problem. No problem, Simran. That's okay. No problem. Okay, so what we'll do is what I want to get started. I always like to get the first class started with a small thing about the course and how I would like you guys to communicate throughout the course. No problem, Simran. How I would like you guys to communicate throughout the course and what is the expectations in the course. And also you guys should have already received the LMS login from the staff on WhatsApp. You guys have that. And I'm just going to give you guys an introduction into the LMS and just go briefly over our weekly plans for the next 10 weeks, okay? And then we're going to start our lecture on networking, which is part 1 of networking, okay? And then you guys are going to have homework, which is going to be watching the week 1 and week 2 pre-recorded video in LMS, okay? Before you guys come into the next week class. And next week, we're going to do the part 2 of networking, and we're going to go hands-on from next week, okay? And then you guys are going to get a small networking assignment, which will be due on week 3. Don't worry, it won't be confusing. I'll make sure to walk you guys through it. And usually at the end of a class, when I say end of a class, just take it with a pinch of salt. What I would like to say is once I upload your video to our LMS, it takes around I would say maximum 24 hours, because it brings it from Google and then it gives it to us and wait for it to upload. Okay. Hey, Gurvinder, how are you, man? No worries. So it takes about 24 hours, but soon as it's uploaded and it's in LMS, you'll get an email from me. You get an email from me stating, it's been uploaded. What is the next class? What we're going to work on. If there's any due, I'll let you guys know in the email. Okay. So as soon as the video has been uploaded in LMS, you guys will get a email from me. Sorry, email from myself to your emails. Okay. So all method of communication in this class will have to be through email. Okay. Just so we keep it professionally, and I'll tell you exactly what course ID you guys will use, and you guys will have to put it in on the subject line before you type the subject line. Okay. And I'll show you all that. Don't worry. Okay. And I'll show you guys if you guys are going to be absent or if you guys are going to be, cannot make it, going to be late. I'll show you guys how to actually do the email, so you guys are familiar with it. Okay. So let me share my screen first. Govinda, are you able to talk?
Hi, sir. Sorry, I joined late. I forgot it. Yeah,
that's okay. No problem. Gurvinder, we just went over about yourself, where you're located, what is your background in education, and if you have any experience in IT. If you just go through the class, just introduction about yourself, please.
Okay, so my name is Gurvinder Singh. I did my bachelor's in India. I came here in Canada in 2019 and did post-graduation diploma here in mobile application development course. And so after I received my work permit, I don't have any technical experience, but I did keep learning like some of the courses. As I said, like I started learning data analyst subjects like Tableau, Power BI. So I learned about this course through your videos, and then I approached you. So I have some coding experience and technical experience, but I still need guidance. Yeah, so that's why.
Okay. Perfect. Very good. Thank you so much, Govinda. Thank you. Okay, guys, perfect. So what I'm going to do is I'm just going to share you my email. Just give me 1 second here. So I'm going to share you my screen here. Okay. So I'm just going to show you my Gmail, and I believe all you guys are using Gmail, so it's perfectly fine. Okay. So first thing I would like to get you guys used to is your Gmail here. And this is on the right-hand side. I have my calendar view here, right? So I'm just going to go into my calendar here, okay? All your classes will be in your Google Calendar, okay? As long as you have approved your email, you should have got an email from, my calendar looks a bit, full, but so you can see all the classes here, okay? So it's labeled by week and what lesson we're going to do on each of these weeks, okay? So week 2 is over here, and it's going to be a networking basic 2, and pretty much each of the week classes are labeled to whatever it needs to be, okay? And there'll be some classes where there's no live lecture. It's meant for you guys to work on your assignment. I'll let you guys know what that is, okay? Those will be your Azure assignment, and they're simulated to make sure you interact with your group through email and communicate and improve communication, and also solve problems, okay? Don't worry, it's not, a lot of people have went through it. Don't get taunted about it, okay? And then we come back and everything is here, okay, in the calendar. You will never need to ask us if you have a class or not, okay? There's no chance of me canceling class. Let me get back. There might be a chance, if there is a chance of me canceling class for sickness or some sort of emergency, I don't cancel class because there's a set amount of days that we have for this course, right? So I try to avoid it as much as possible. Health reasons or some sort of things that happen, I will try to let you guys know through email at least 1 day before, okay? And if I remove it out of my calendar, it should be removed out of your calendar too, okay? As long as you click yes on the email that was sent to you, maybe on the 19th, I believe. They should have sent you an email on the 19th. If you guys did not receive it, please send them a WhatsApp message and they'll send you again, okay? Don't hesitate, okay? So everything should be in your email, in your calendar, okay? Now in your email, whenever you're going to write a new email, I want you to do is, if you're going to ever send an email out to everyone, and I want you to do it in a group email, okay? And the easiest way for you to do it is, if you click on your calendar here, you can see all your classmates' email over here, okay? Just copy it and paste it in the 2. There will be CTech Training Center here. Just put that in CC, okay? And don't worry, this is getting recorded too, so I will put on LMS as well, okay? This will be in the LMS. So this will be your classmate, and if anything changes, going into the calendar and getting it will give you the newest one. Okay. And in the subject, you have to have this. Okay. This is what identifies you, which batch you are in. So IT help desk ITHD-MAR26. Okay. And this is on your Google invite too. You'll see it on your Google invite. This is your class batch number. Okay. So if you put this in, and then you can put a colon or whatever it is, just leave a space, and then put in your whatever your email is, right? If you're going to be late, just be like, I'm going to be late. Or if you're going to be away, just make sure you broadcast out to your group. Okay. The reason why you need to start broadcasting out to your group is if you're going to be late, or if you're going to be sick and away, or if you are having any sort of help in assignments, your teammates, okay? Start a group with their team. They need to know where you are and if there's any sort of help or anything like that, okay? And IT, if you once you start watching a pre-recorded video, you'll find out it's not an individual game. This is a team game, okay? So your team has to be updated as well as you. Okay, and I can just put in, I'm just going to do this as email chain here. Hi team. I'm going to do first email. And I want to send it to you guys, okay? So when you guys receive it in your email, let me just go ahead and give it a second, okay? So let's say if you ever are replying to any sort of emails, right? So let's say, let me go back to here. Okay, so let me go back to here. Okay, so whenever you guys replying to email, there's one thing that you guys have to change in Gmail, and by default, Gmail has it where it's only, you see how it says reply all for me? In your side, you might see only reply. So you need to go ahead and change that. And the easiest way to change it is going into your settings over here and going into see all settings. And then if you see here, default reply behavior, just change this to reply all and then click save. This way, by default, you can do reply all to everyone, okay? So if you were to go here and just do reply all, you're automatically replying to everyone, okay? And this will create a chain. And each assignment will have its own chain, okay, that I want you to talk them in within. That way we can see if anyone needs help, if anyone's, if the guidelines is slightly going out of scope, I can come in and put you right in scope, okay? And it's very important that you guys stay within this chain and use this code as your first thing, okay? So that I know which batch you're talking in. Because we do have sometimes simultaneously 3-4 batch running at the same time, and each will be doing a different set of activity. They'll be in different weeks, right? So it might confuse me. This batch will help me to identify which week you're in or which type of question you're asking, okay? Any questions so far about the email?
All good, sir.
Perfect. Thank you so much. Okay. Now, let's go into our LMS, okay? So your LMS login should have been sent to you. It's called ctechtraining.ca, okay? When you go in, go here to log in. Okay, let me log in here, okay? This should be a login. Now, for me, because I have a lot of courses I teach, it's there in my portfolio. But in your portfolio, you should have only one that is you're associated with. And it should be the March IT Help Desk March 26, okay? This one. And this has your Google Meet link as well, just in case if you could not get it, this is your link, okay? Just in case if you forget. But I always suggest go and get it from the calendar, because sometimes this link does change, okay? Google does decide to change this randomly. This has been happening this year only, so never happens before. And if you're ever never sure about what's my email or CTech Training Center's email is, this is my Gmail email. You can get it from your LMS, and this is CTech Training Center's Gmail, okay? This one over here. Next over here, this is your ticketing system login, okay? This one will actually go ahead and do some assignment with it later on, just slightly later on in the course, because you will have to get used to ticketing system, okay? This is a pre-built ticketing system by us. We maintain it, but you guys will have a login forever for you guys to go ahead, play around with it, create tickets and those type of things, okay? This is used for support purposes, okay? Now, when you scroll down here, give me one second. So when you scroll down in here, it's broken down by weekly, and it has all the red ones. All of them are pre-recorded, okay? And the green ones, there'll be videos in it. There'll be, right now there isn't because this is a class. It'll be in here for the pre-recorded class, okay? And as soon as I put it in there, I'll send you guys an email to let you guys know, okay? And the second week, you don't have to do this assignment right now. This is for next week. When you guys do the live class, I'll let you guys know about this assignment. And then you'll do the assignment. The assignment must be handed in through email, okay? And I'll show you guys how to handle the email as a PDF. I'll show you guys next class. Don't worry about too much about it. But each week will have its own pre-recorded thing until week 4, I believe. So there's not much afterwards. Everything's live. The reason why these are some information good to know, but they won't really cause. They're not really. We don't need to really cover them in live in class, but we'll discuss them next week. Okay? Every time there's a pre-recorded, we will discuss them in the next live class. But next week when you guys come in, please watch the week 1 pre-recorded and week 2 pre-recorded, okay? So you guys will be fully caught up for when you guys come into the live class next time. You don't have to do the assignment yet, okay? The assignment will be done on the 3rd week, okay? Any questions so far, guys? Perfect.
No, sir.
Perfect, thank you so much, okay. All right, now what I'll do is I will switch you guys to the slides. Give me just 1 second here. Okay. And what we will do is every 1 hour, so this is a 2 hours class. So at the 7 o'clock mark, we'll take a 10 minutes break, just so you know, you guys can go and grab water and those type of things. And also, if you guys ever need, before I get started on the class, I always say this: if you guys don't understand a topic, please unmute yourself and ask me, and don't let me go proceed, because you guys are individually paying for this class. Okay, so you guys need to understand that you need to properly understand this concept. And sometimes the way, for some people, it doesn't, and it might not be straight away clicks for you guys, right? So when you tell me to say in a different way, I can put into 100 different type of different examples until you guys understand, okay? And you guys need to individually understand this. Please, it's in you to ask for those type of things, right? And don't ever be shy. And there's no thing as simple as silly questions, okay? Even if you think that this might be a small question, still ask and get it clarified. Because one of the things that I've seen successful people is, when you're able to explain a small concept to a little kid and make them understand it, that's when you have fully understood a concept, okay? So until you can explain to someone with no technical skills, that's when you're successful in this, okay? So think of it that way. So that's very important, and that's what it means you understand the concept very well. And a lot of times when you guys will deal with a lot of end users, they don't know a lot of technical terms, so you cannot use technical term, but you need to know the technical term so you can tell your team. But when you talk to the customer, you need to be able to say it in a way that's very, very layman terms, right? So that's why it's very important. Some people understand it a different way, so I would never ever tell you, no, this is enough, right? So if you have any questions, please write them down, even from the pre-recorded video, and ask in the live class, okay? That's what I would ask from you guys. All right, just give me 1 second here, guys, okay? Just 1 second, please. All right, man. I'm so sorry, guys. Okay. All right, so we're going to be talking about networking fundamentals for IT help desk support. Okay, so we're not going to go so deep in that it's for covering for administrator, but we're going to make sure you understand the concept of it, and we're going to go through troubleshooting in the part 2 as well. Okay, this is going to be lecture class. So, what is a networking? A networking is a group of devices connected together. Device communicate to share data and resource. Okay, can be local, like in your home or office, or global, like the internet. So internet and your home are actually two different type of network. And in your home, we call it as a private network. When you are online, like Rogers, or when you're going on a website, those are called public internet. Okay, and I'll show you guys in part 2 how do you actually diagnose what is the difference in visually, so you guys will have a better understanding of it. Example of resources shared are files, printers, internet, and application. Okay, this is what you can share in the network: files, printers, internet, and application. Okay, why do internet exist? A network solves a common problem. It saves money, enables communications, helps collaborations, and centralizes management and security. So I'll go over all these points. So what does it mean by saving money? So back in the day, when, I don't know if you guys are old enough to remember, I wasn't that old too. So back in the day, there used to be something called DSL modem. And this would be a phone line modem that you'll get from Bell or Rogers. You have one cable that it's like a phone line cable, connects to your computer. Your computer will dial up, it's called dial-up connection, and get internet access. And these are in kilobytes per second, and you get charged per megabytes you use. 1 megabytes were, I think, like $20 or something like that. Back in the days, $20 or $25 per megabyte, right? So it's very expensive, but you can only have one computer connected to the internet at a time. You can, and if you want to have a second computer connected, you have to have a second DSL modem, a separate connection for it. Okay, which become very, very expensive in back in the days. I'm going to get to what is the solution to it later on, but that's what it means to save money. What happened was then, when we started saying that we can actually network these devices and have one modem can be shared among 30, 40, 100, 200 different devices. Okay, so we're now able to get one single line from Rogers or Bell, but connect like 40, 50 devices. And if you guys look at your home right now, in your home router, you guys probably have 20 devices easily connected to it. Okay, and it's all possible because of network existed. Okay, networking was existed. It enables communication. Part of the networking, why it was actually built by for military purposes. Okay, it wasn't built for us to watch YouTube or to have a video call, but it was built for military purposes, for sharing intels very quickly, or sharing information very quickly, right? Intelligence information very quickly across borders or different military bases, right? But then we found out we were able to do communications, video calls, and everything as well for civilian purposes. Okay, even our calls, our cell phone calls, are going over VoIP, voice over IP. Okay, they're no longer going through a traditional line. Even our 5G calling, it is voice over IP calling. Okay, it enables that, and enables collaboration, which means in a network or globally, we can actually send files and work on a file at the same time. Teamwork, right? Like if you guys remember, you guys can actually create a Google Sheet and share that sheet among like 40 different people, and 40 different people can actually log into the same sheet and work on the same sheet together, and without corrupting the sheet, right? It enabled us to do a lot of shared and teamwork with it. Okay. A centralized management and security. In a workplace, we actually have a setup, something called a server and a client PC setup. Okay, what it does is, a client PC is like our laptop, whatever you use, our laptop and those type of things, will connect to something called a server, which controls it, which can monitor, control, save, and do everything, right? It's a centralized management. With that, what we can do is we can actually monitor, we can actually centralize, manage the end device. The end device are laptops, cell phones. You can actually do your tablets, your smartwatch, smartphone, whatever it is. Okay, those are some things that end users will use. Okay, end device are what is used by end users, and we have servers which are used by the administrator. Okay, You guys will be using a service now. It's all been virtualized, and it's called the cloud. That's in the cloud, okay? And Azure is a server that gets to control the devices as well, okay? It's a service it's virtualized now. We'll go a little bit later on how that works and everything, okay? No worries. But just think of it this, instead of now having a physical location with a physical machine and everything, it's just all virtualized. Virtualization means nothing other than somebody else has a machine for you. They will manage the power, they will manage the network and everything, okay? It's still a machine. It's still at some other place, but they're just managing it for you, okay? You don't have to manage it. And in one of the pre-recorded videos, we do talk about virtualization and how it works, okay? So you guys will have understanding of virtualization. Without a network, every user would need their own internet connection and a printer. Well, when we share a network, we can actually share a printer in a network as well. If you guys go into offices or into schools, you guys will see like a big, gigantic printers like laying in one corner, right? And everybody can print and go there and pick it up, rather than everybody having a small printer in their desk. And printers are, if you think about it, printers are not actually expensive. It's the ink, right? Printers are cheap. Like you buy a printer for 49 bucks, but if you go to buy the ink, they're like 80 bucks. It's because the ink itself is very, very valuable. But in a corporate environment, when you go like that and when you print like 10,000 pages per day, that is very expensive for them, right? So when they can like share those large printers among 20 or 30 or 40 people, because they're not printing all the time. They're printing maybe, 10 times a day, and those are not matching with everyone, right? So that's fine. So they would share a printer, and those printer are what we call a network-enabled printer, okay? They're called a network-enabled printer. So these printers can connect to a network and can be shared in a network. Any questions so far, guys? What does a home network look like? Okay? So this is what a home network looks like over here in the diagram over here. So if you see here, this is called the Internet Service Provider. In technical term, we call them ISP, okay? So memorize ISP, it means Internet Service Provider. Your Internet Service Provider will run a cable to your home, which should be connected to your modem at home, okay? Right now, you guys all will have something called a router, or a Bell or Rogers will give you guys a small box that looks like this. Back in the day, when I first came to Canada, 2005, we actually had a separate modem, and we have to go and buy our own router and put it in, right, from Best Buy. It was like $150, $160 for these routers. But Rogers will give you a modem, you have to rent it. But this modem, all it does is it has a coaxial cable plug-in, like a TV cable plug-in, and then you can plug in one internet cable. Your router has many, but like your modem only has one. And it's because it's meant to be plugged into one device, that's all, right? So your router enables you to do networking. But your router can connect wired and wireless. So what does a network in a home look like? Devices you can connect is a phone, laptop, tablet, smart TV, printers, pretty much anything, okay? Wired or wireless. Routers connects to ISP and shares internet. All the router does is it connects to the ISP and shares internet through a modem, okay? Modem has two sort of connections only. It'll have a coaxial cable and it'll have one Ethernet jack. So one is for incoming, one is for outgoing. The coaxial cable is for incoming, the Ethernet cable for outgoing, okay? That gets plugged into router, okay? Any questions so far, guys? Clear? Perfect. Okay. So this is what an office network looks like, okay? You have the same internet, ISP, and you have the modem. Now, in a workplace, right, you see the router, this is just one. But if you see here in workplace, it gets split into like three or four different devices. You see the modem is still the same. The reason why we like to split them up into like couple of devices is this is a router / a firewall, okay? And we have a switch over here. Switch is nothing more than like, it allows you to plug in like 20, 30 plug-in cables, okay? It's cable where you can physically plug in. And next class, I have a physical one upstairs. I'll bring it downstairs and I'll show you guys, okay? I'll show you guys how this will look like. And we actually have something called a Wi-Fi access point. These are Wi-Fi devices. And these devices, all it does is you can only connect one cable in there and it'll allow you to do Wi-Fi. And these are what you'll see on the ceiling in the office. And there'll be like a disc or dome type of thing, okay, on the ceiling. And if you see here, in the home one, we have a modem and a router. Now we only have a router at home. If you guys see your home, you guys will have only one device, which is a router, okay? But even now, when you go into office, you'll have like one modem, you'll have 2-3 routers, and you have 10-15 switches, and you have hundreds of these Wi-Fi devices. The reason is this: in a home, let's say if the modem I don't know if you guys ever had issues where the modem failed. It just stopped booting up, or doesn't work. And Roger's Bell was like, oh, okay, you know what? Your modem is busted. We have to ship you out one. It'll take 2 days, right? Which they're telling you the 2 days, and you're like, fine, okay, fine. You can't, because you have no choice. But in workplace, when the workplace is dealing with hundreds of millions of dollars per day, if you were to tell them, you know what, you're out of internet for 2 days, they'll come and choke the ISP's throats. So they like to split these up. So even if they have one Wi-Fi device fails, it's okay, because they have hundreds, and it'll overlap them, right? If they have 15 switches, if one fails, fine, no problem at all. What they'll do, they'll just move all the cables to the working switch and keep them working. And if they have 2 routers, one router fails, they can just still make the other ones work, right? And usually modem as well, they'll have 2 different modems. So usually, for me, my background is in the public sector. So I usually do a lot of hospitals, private jails. Private jails means they're called hold and release jails in Alberta, Saskatchewan area, and BC. And when we used to do them, right, you have to have 2 separate internet providers, ISPs. So I know in Saskatchewan they used to have Saskatel, and we would get Starlink. So just in case if Saskatel ever goes down, Starlink still will work, and we have 2 different modem, right? So at any point, in any given point, the jail will not be out of internet, because every door system, lock system are controlled through those internet, right? They're all through network. In case of network goes down, there still is a backup generator they can turn on to control it manually, but it's still an unnecessary thing, right? So they try to make sure that internet is available, okay? And hospitals always have 2 connections. A lot of corporate offices, they'll have Rogers and a Bell, just in case if one goes down, okay? And Rogers knows if the Rogers modem goes down, they have like 24 hours rush, or they have a rush service, so they can provide it to the workplace in a very quick manner, okay? That's why it's split up into the thing, and it connects the same thing. Whereas there's wired connection gets separately into the switch, and the access point, or the Wi-Fi device, can control all the wireless devices, okay? And those can be mapped out, and it can be balanced out. And I'll show you guys next class. I'll actually physically have it here. I'll bring it down. But those things, you'll see one of those. It's called AP. A as in alpha, P as in Peter. Those are what's called AP access points. Okay, those looks like a disk, and I'll show you guys next week. All right. Any questions so far, guys? Clear? Perfect. Okay, so this is what we call as a feature table. Okay, just to give you a good idea of the difference between there's a high reason why a lot of times when you go into workplace, this computer can be wireless, but they will want it to be wired. There's a reason. Okay, wired, it means speed is a lot more faster and more stable. But Wi-Fi is slower, can fluctuate. Okay, it depends on how far you from the modem. It can be faster or not, but it would never be faster than being plugged in. Okay, so being plugged in is always faster. And the most valuable thing in the plugged in is being more stable. It's a more stable connection, whereas Wi-Fi can fluctuate. Reliability, wired has a high reliability, not affected by walls or anything that's interfering with it, right? Whereas wireless signal can have interference. If you have a microwave, and if your router's on top of your microwave, if you turn on your microwave and you go beside it, your Wi-Fi signal will fluctuate, and you'll see that actually your device will not connect, because your microwave, like your thing to heat up your food, will actually interfere with your Wi-Fi signals. That's why they came up with the Wi-Fi 6E. Those are out of the Wi-Fi. The radio waves are out of the spectrum, so they don't get affected. But the older Wi-Fi that we still use at home and in office, in a microwave, it does affect. Like cordless phone. Remember back in the day, we used to have home cordless phones. Those will affect Wi-Fi. There's a lot of things, like anything that's wireless will affect Wi-Fi. Okay, before. Even still now, depends on the ones we have. Even my home, I don't have Wi-Fi 6E. It's very expensive. I only have Wi-Fi, I think the 5G, so which is fine. But but it'll still get affected if I have on top of a microwave. Okay. Whereas flexibility, this is when it goes. This is where we go in Wi-Fi more. Whereas flexibility comes into place. Wired is not flexible. It needs to be there, right? You have to run a wire. Whereas Wi-Fi is more flexible. It's meant for mobile devices. Wired is used for on a desktop and servers, whereas wireless is used on laptops, phones, tablets, smartwatches, whatever it is. Okay. The next thing is why, in some cases, even in desktops, they use wireless. Okay. So desktops can use wireless and can do wired. Okay. Typically, desktop do only wired, but you can add in an extension, make it to work with wireless. Okay. It depends on the computer. Servers definitely are wired. Okay. They're not used in wireless. They have to be wired in. It's because they need a stable connection, because they're now servers are what controls a lot of devices. They monitor a lot of devices. They need a lot of input and output, which means that the internet has to be stable and fast. Okay. It is directly connected by wired. Okay. Any questions so far, guys? Here? Perfect.
So yes, sir, I have a question. So the modem that we have in our house, like, can we like if we need to use our like laptop through wired, like, do we need a HDMI cable or?
No, Ethernet cable. They're called Ethernet cable.
Okay.
So they look like, you know, your phone line, right? So you know how, remember back in the day we used to have phone line cables?
Yeah.
So they almost look like that, but it's not. Here, I'll show you. They're called RJ45 cables. Okay.
Okay.
So they look like this. So you can actually do a direct plug-in. They look like this. They're almost like the phone line cable. The phone line will have four pairs, I believe. But the Ethernet cable will have 8-pair cable. Okay. You see, there's 8 pairs inside.
Okay.
They'll get connected into one clipping over here. Okay.
Yeah. Thank you.
No problem. Any other question, guys? Okay, perfect. What an office network look? Oh, sorry, this one's done. Okay, so and I want you guys to just remember this name and memorize it. Okay, Node, and you guys will hear it maybe somewhat throughout your career. And Node, when they say, it'll tell you guys, don't think of it as a big word. We say node is because it's node equals to anything that connects to a network, anything that connects to a thing. It could be a computer, it could be a phone, it could be a printer, it could be a router, it could be a server. Okay, anything that is receiving what we call as the IP address from your router. Okay, anything that's receiving address from your router will be called as a node, because to your router, it really doesn't care if it's a computer, phone, printer, router, or a server. It doesn't really care. All it is as long as I can, the router thinks it this way. As long as you're borrowing your IP address from me, you're going to be considered a node. That's all it is. Okay, so when they tell you node, automatically think it could be anything: computer, phone, printer, router, server. Okay, that's all. So this is what we call as a layer 7 in the OSI model. You don't have to memorize this. Okay, this is not something you need to memorize. Don't worry. It looks very big because this is how your internet used to work. This is like back. This is when internet was first getting introduced, and this was a back in the day technology. Okay, but why we want to see this is how your internet used to work, and right now it's been condensed into a 4-layer. Okay, you guys don't have to memorize it. It's only for the networking guys. But the reason why I put this in here is always, whenever you're troubleshooting, whenever you're trying to fix something, start with the physical. So you see, even the networking, they always start with the physical. It means a connection first. Okay, even in the networking, when they first came up, it's this connection first, and then what we call as a physical address. Okay, physical address are something that is your device has. So even your phone, your laptop, if you have a thermostat that connects to Wi-Fi, it has to have something called physical address, which is called a MAC address. Okay, MAC address. This is made by the manufacturer. This is actually unique. It is generated through manufacturer. If you, like, for example, if you go on your phone and go into settings, I have an iPhone here. I don't know about Android, but there is, but I just don't know how to go there. But if you go into your settings and about, you can actually see something in settings and about on iPhone. And if you scroll down to your thing, you can actually see something called Wi-Fi address. That is your physical address. Okay, so what this is basically saying, if I want to come and borrow money from you, right? You're gonna be like, okay, you're not gonna give money to a random guy. You're gonna probably be like, okay, what is your name? Can I see your ID? You need to know who am I, right? Like identification. So this is basically identification for each device. And for you to receive communication from your router, you need to have a MAC address. Okay, or else the router will be like, I don't know who you are. It just cannot even communicate. It cannot start the communication process, okay? So the MAC address is very important. And then the rest of it is just about networking. It's about the concept of, networking, IP addresses, ARPs, and those type of things, okay? We will go through these later on the slides as well. We have the end-to-end user communication. We have interhost communication, data presentation, and application, okay? But honestly, in our concerns, we're worried about these three layers, which is network, data link, and physical. Data link is your MAC address. Your network is your IP address, okay? These four, we'll actually do some of them in part 2 of it. You'll see how the transport layer works. How does your computer actually communicate between different websites, different computers? How does it go? And I'll actually show you how you can actually see the route your network takes to travel to that location, and you'll physically see it in your thing. And we'll do some class activity where you guys will give me a public IP on your side, and we'll actually try to come to your house networking. Okay? We'll try to do a visit to your house. It'll be fun. Okay, now we're going to talk about IP addressing and subnetting, okay? These are some things you do have to fundamentally understand, because they're going to be your bread and butter pretty much when you're doing troubleshooting, okay? Everything, most likely you'll get a call is because either I cannot log in or my computer cannot connect to the internet. Those are two things that you'll get majority of the time calls. And you need to know how to differentiate between a user error from a network error that's behind the router, or if it's getting blocked by a firewall, okay? We have something called firewall in IT, is to block any incoming or outgoing connection that can potentially put the company at risk, like viruses. If your company has a policy that says you cannot watch YouTube videos, you cannot watch YouTube videos, So if a user calls, you need to know that, right? So there's actually a proper way of testing these, and we'll go in the next class. We'll actually do part 1 of it, and then we'll do part 2 slightly later on in the course. But we'll do part 1 to next class, so you guys understand how the troubleshooting or how the networking traveling works. Okay. All right. Understanding IP addresses and subnets, the language of networking. Okay? This is like your basic introduction to networking. What is IP address? IP stands for Internet Protocol. It is like a home address for a device on a network. Every device needs one to communicate, okay? There's 2 different types of IP addresses, and I'll explain why there's 2 different, okay? The first one that was ever created, it's called the IPv4 address. It is numeric digit, okay? It's only numbers. It's very easy to read for us, and we know and we can memorize it. And it's most common internally. So in private IP, it's very, very common, okay? And I'll explain why just in a couple of minutes. We have something new. This is new, meaning this is about 10, I think 20 years old, which is called IPv6 address. This has numeric and alphabetic, okay? Both characters mixed in. It's newer and it's longer, and it's not easy to memorize. And the reason is because, remember I told you, internet was not something that we were creating for everyone to use. It was actually created for military purposes, for certain purposes, right? They had maybe 2,000, 3,000 units across the countries, maybe different countries, right? Like, it wasn't supposed to go beyond 4 billion IP addresses. With IPv4 address, you can only create 4 billion IP addresses, okay? You cannot create anything more than 4.3 billion, I think. Yeah, 4.3 billion IP addresses. Well, if you take a look at it, how many of you guys have a, cell phone, laptop, smartwatch that connects to internet, right? Those things all require IP addresses. We'll go over 4 billion. We've already went past 4 billion, okay? And if you go back home in my country, everybody has 2 cell phones, Everybody has 2 cell phones and a computer, right? So like it doesn't work out. And I know I used to live in India for some time, but when I used to live in India when I was young, I know even then internet was a thing. And now when I go to visit India, everyone has 2 cell phones, broadband connection at home, and some sort of smart device also that has a private connection, right? So we've already surpassed 4 billion. But when they saw this 20 years ago, they're like, okay, we need to do something about this, or we're going to stop. We're not going to be able to use internet. That's when they came up with IPv6, which has, I believe, 300 octillion or something. It'll take us next 100 years to use all of them. Even if we give 10 IP address individually for them to use, privately or individually to use, we will never run out of IPv6 address in the next 100 years, I think. Something like that. It's enormous numbers. We will never use it. That's the reason why IPv6 was developed. Okay, and as I said, there's something called a public and a private IPs. Okay, the reason is because I want to show you this, and I'm gonna show this throughout this thing. You're gonna see me open up Paint, and I'm gonna draw. Okay, for you guys. And don't expect me to draw very well because I'm not a good drawer, but I know I can tell you guys a story about it. Okay, so let's say this. Okay, let's say you have, this is your home. Okay, we'll do home as green. And then you have the internet, okay, which is your Rogers. And right now, this might not make sense. Don't worry if it doesn't. When I do the experiment next week, and I'll explain it again, this will make a lot of sense, okay? Your router or your modem at home, where it sits is it sits right in between, and I'm going to do this in back. It actually sits right in between. This is how your modem or your router at home, this is how it literally sits. It's in between. What it does is it literally divides it into two different sections. Okay, that's the reason why it's able to give you. Remember, when it was created, it was meant to be used for one device. This is the reason why it can actually allow you to connect 30, 40, 50 devices inside the home, is because it creates its own small network from what Rogers has. Right, Rogers has a network, but it gives you only one connection. Your router does the same thing, but in a small scale for your home scale. Right, so you can have, you know, two of these. You have a computer, you have a TV, you have a thermostat, you have a smartwatch, you have those, you know, the frames, the photo frames, whatever it is, right? Desktop, maybe another laptop, your mom's cell phone, your dad's cell phone, your sister's, you know, iPad, whatever it is, right? These all have to go through these one router and connect to the public internet, okay? This public internet is Rogers, Bell, whatever it is, okay? This could be Rogers, whatever you can think of. Not a problem at all. Rogers, Bell, I think there's Virgin and everything. This is where the public is, where all your internet is located. This is where all your Google is located. This is where your YouTube is. Any website that you can think of is in the public network. It's not in private. So this is, if you think about it, this is how it is. Okay, so this is your private. Network. Next class, I'll show you guys how to get, because each one of these will have their own IP address. So there's actually different IP address for private that you have in your home, and you have another set of IP address that is on public side, okay? That is faced on the public. Because remember, Rogers only giving you one address. You're the one who's doing the internal, you're creating multiple addresses, right? So, okay. Oh, I thought it disappeared. Any questions so far, guys? Everybody following along?
All good, sir. Yes.
Perfect. Yeah. Very good. Okay, so that's what public and private IP. Okay, and your router, that's usually sits in the middle. It takes in all the traffic, passes through like a bridge, and brings back anything it needs. Okay, and your router does a little bit more. Your router is actually really smart. It actually knows who asked for what. Okay, and who needs what information, and pass it on to the right people. And he uses MAC address from the device, and the IP address it gave the device to understand who asked for what request. What is subnetting? So remember, in a home internet, we only have 40 devices, 50 devices, right? But in a larger corporation, right, you have 3,000 people, 4,000 people. That's when you need to start separating the network into small chunks. You want to have a separate network for HR. You want to have a separate network for management. You want to have a separate network for IT, because HR can have 200 people working in it. Or you can have you can have nursing, in a hospital. You can have all the doctors can be in a separate network, or all the people in one area of the hospital can be in one network. It just makes it easier for the network admin. You guys don't need to do it. It's a network admin. It makes it easier for them to manage. Okay, where it becomes harder for you guys is understanding that sometimes if you're in different networks, if you're a part of a different network, you cannot communicate with each other, okay? It'll block the communication unless your network administrator allows the communication to go through, okay? And we'll actually see, I hope next class, one of you guys are on Bell or Virgin or something like that, so I can actually tell you guys how this works. And I hope 2 of you guys are in Bell, or like a couple of guys in Rogers, and you guys, I'll show you a live demo of why this really, the being in a separate network actually is, it makes a huge difference, okay? Unless they allow for the communication to happen, you can talk to, the devices can talk to each other if you're on different network. But if you're on the same network, you guys can talk. You guys are family. Okay? Think of it like that. If you're in the same network, you're family. But if you're in a different network, you're almost like, you don't know each other. Okay? You guys understand?
Yes.
Yes.
Okay, great. IP address and subnetting made easy for helpless analyst. Let's make IP simple. Every device on a network needs an IP address to be found. It's like a phone number, unique, and it tells where to send data. Remember, to receive an IP address, you need to have a MAC address, okay? So without a MAC address, you'll never get an IP address. And when you get an IP address from the router, you're getting an IP address from the router, okay? Your router. You're not getting from Rogers or Bell, you're getting from your router, okay? Because your router, remember, is the one that's in between, right? You're actually talking to your router rather than ISP, or the internet service provider. So for you to get an IP address, you need to have a MAC address, but you never, like, when your device, let's say this laptop gets an IP address, this laptop can never own the IP address, okay? You can only borrow it. Just think of it like that, okay? Think of it borrowing it. But the router can give the IP address to the laptop for a long period of time, that's fine. But it is still considered as leased, okay? Like a leased IP, or leasing a home or leasing thing, okay? You're leasing an IP address from the router, okay, at any given point in time. And we'll talk about 2 different types in it. I don't want to over confuse you in this class, but its IP address has to be unique, okay? You cannot have the same IP address on 2 different devices, 2 or more different devices on the same network. See the language I'm using, on the same network, right? But if you're on a different network, you can have the same IP address, it's fine, because that's separate, right? That's internal. But if you're in my home, me and you cannot have the same IP address, or else it just doesn't work. The router will never assign it to you like that. But if there's something called manually assigning yourself. If you even manually assign, both devices will not work, okay? It'll stop working on both devices. The internet will not work on both devices. 2 main type, we talked about it, IPv4 and IPv6, okay? IPv4 is easier to read. IPv6 is more complex. It's more future-proof. Now, there's 2 different type of ways you can get an IP address. One is called dynamic IP address, or static IP address. Dynamic means the router leases to you for 3 hours, 6 hours, 24 hours, 30 days, doesn't matter. The network administrator can say, okay, per every 24 hours, I want you to take back all the IPs and recycle it, and give it to any device that needs it, okay? The reason why this is very important is, remember I told you on a network, right? On an IPv4 level, you can only create 4.3 billion IP addresses inside of your home, okay? That's the maximum. But typically, your home network can have 255 devices connected on the router itself, okay, at any given point in time. But let's say if you don't take back the IP, right? And I'm going to talk about this in a workplace, okay? Not at home, because your home, you don't really get that much visits. I don't know about your home, but in a workplace, let's say you have people coming in and going out, right? Like sales or new people coming in and going out, and every time somebody connects to a router, to the Wi-Fi or something, they'll be given an IP address, right, to lease. Now, if I don't get the IP address back from them, what happens is, after I run out of 255 IP address, that's a network size, okay? And different network has different sizing. You guys don't have to get that complex down, but understand that each network can have a different network sizing, okay? You can go from 2 devices all the way to 4.3 billion devices, okay? But you can set a limit, and usually, typically, it's 255 devices per network on a typical network, okay? Typical. So let's say if somebody's walking out and I have like delivery, somebody's like coming inside into the Wi-Fi, okay, and if the router is set to only renew the IP address every 30 days, if in 15 days I already leased out, the router actually leased out all the IP address, the router will be like, all right, man, I give out all my IPs, I don't have any more IPs. None of you guys can access the network anymore. It will just stop the network connection, okay? So it becomes an issue in a high pace environment. So what they do is they set the lease period to 3 hours or 2 hours, okay? Typically I seen the lowest is like 6 hours, okay? Every 6 hours, even if it's given to you your laptop, give you your laptop an IP address and your laptop is not in the facility, you would still remove it from who it's assigned to, because it's only letting you to borrow, right? Remove it from its internal memory, who it's assigned to, and put into a bucket where it can be lent out to someone else. Does that make sense, guys? I know for some people that might confuse it. If you don't, please let me know and I'll rephrase it.
I got it.
Okay, perfect, yeah. Okay, if you guys don't, please let me know and I'll rephrase it, okay? So that's the reason why it's very important for the lease time to be understood. And there's a way how you can check your lease time, and I'll show you guys all next class, okay? How to check the lease time and how to actually renew and release those type of things, okay? You can actually manually renew and release. The next thing is, it's called statically adding an IP address, okay? You can actually go into your computer, and if you know this IP address is not being used, so you need to know. That's the first important thing. You can actually tell your computer, this is what you're going to use from on now, and your router will be like, okay, yeah, I have this free. All right, I'll give it to you, right? But before, back in the day, what happened when we used to do this was very typical of it happening, okay? So for, let's say 1995, we bought a computer in. We set up a static IP on the computer. We're using it for 5 years, 6 years, no issue whatsoever. Now, 5, 6 years later, we got a new computer. So we turned this computer off. We put it in storage. We got the new computer, set the same IP address, right? Because we were using the same IP address, we're used to doing static. And we start working on it, okay? Randomly one day, the audit comes in, and they're like, hey, we want to see all your files from 10 years ago. Oh, we're like, oh, we have it in the computer, we have it in storage, no problem at all. Okay, let's bring it in. Let's plug it into the internet, turn it on. 20 minutes later, both computers stop working. Okay? Stop working means it doesn't communicate with the internet. It cannot connect to the internet. The reason is because if your router sees 2 different nodes having the same IP address, you see how I said node? So which means the IP address, it doesn't matter what's assigned to. If there's 2 IP addresses on the same network that are the same, your router will be like, all right, you're both are timeout. We're not going to let you, both of you guys cannot access the network. The other computers will start. The other computers will work as normal, okay? But the 2 nodes with the same IP address will not work on the network. You can still turn it off and turn it on, do everything that's on the computer or the node itself, but to connect to the internet and connect to the network, it will not work. The reason is this. Imagine if you're working in Canada Post, okay? You go down the road and you say, okay, you're supposed to get a mail to, let's say our building is 4168 Finch Avenue East. That's where our building is, penthouse 05, right? Okay, you climb up the stairs and you come up, you turn right on the elevator, you come down, you see the penthouse 05, and you're about to knock and you turn right and you see another penthouse 05. There's 2 doors with penthouse 05, and none of them are answering, right? What do? The Canada Post is like, all right, this is a confidential document. I'm not going to send it to both of them because I don't know who this. You guys need to solve it, right? So that's the attitude that your router will take, because you both have the same address. There could be information that I can share that is not meant to be yours. So I'm going to stop all communication. Okay, that's what your router does. The only way to avoid this is to have it in dynamic or DHCP mode. Okay, dynamic IP mode, which is called DHCP mode. Okay. Now, in the future, right now, we do set some stuff in static, but we set it on the router side, okay, with the MAC address. We say, because we know this device has a unique MAC address, right? We say, if this MAC address enters the network, always give it this IP address. That's the proper way of assigning now, okay? Which means it doesn't matter where you go, as long as this MAC address matches, it'll put the IP address. And the router will tell you, if you ever try to put that same IP address on a different MAC address, it'll tell you, no, you need to remove this MAC address first, because I don't want to assign to 2 different MAC addresses, right? So that's the smartest way to do it now, okay? You guys will not do that. It's probably network admin, but I'm just giving you that as information, okay? And usually, where static IP is used is on a printers and servers, because you don't want the server address to change. or you don't want the print address to change. Okay, so it's always set to static, but on the router, not on the device. Okay, and I'll show you guys how the static IP needs to be set on the device next class. Okay, guys, it's 7 o'clock right now. Let's take a 10 minutes break so you guys can have water break. Okay, so let's meet at 7:10. Okay, guys, let's meet at 7:10. Thank you. All right, guys, I'm back. Okay. So subnetting without MAC, subnetting without math. You guys don't have to get too depth into subnetting because it's a whole entire world itself. But think of subnet like breaking a big apartment building into units. Subnet makes telling where the network ends and where devices begin easy. For example, I'll show you what this means. Okay, in the demo class next week, your network will have a subnet mask of 255.255.255.0, which means you can have 254 devices in the network. Okay, on a typical home network, this is what you'll have. See, and I'll show you guys exactly next class where to go in and see this through a command line. Okay, and you guys will get exposure to command line next week. Any of you guys using Mac computer, or all of you guys using just Windows? Using Mac? Okay, no worries at all. Okay, I'll show you how to do this in the Mac too. It's the same thing. The command just slightly changes. In a corporate environment, you will use Windows. Okay, so you will have to get used to the Windows commands. It's very thing, but you can do the same command, similar command in Mac to get the information. Okay? Not a problem at all. The information might slightly be different, meaning the display will be slightly different in the Mac, okay, than a Windows computer. Okay. So real help desk example. So when they tell you that they're seeing an IP address, the reason why this is there is so you guys memorize it. If they ever tell you their IP address is 169.254, which means they're not getting DHCP, okay? The DHCP means they're not receiving dynamically assigned IP address from the router, or they're not getting any sort of IP address from router, okay? IP conflict means two devices using the same addresses, two or more devices, okay? Typically, if there are two or more devices using the same address, you'll get something called IP conflict. When users complain cannot connect to printers, you need to make sure they're on the same subnet, okay? And I'll show you guys in the next class how to actually take a look at that, okay? No worries. The 169.254 is something you guys will need to remember. It means the router is not issuing an IP address. Your device might be connected to the router itself, but is not receiving an IP address from the router. Okay, so from 192.168 to the internet, IP addressing and subnetting basic. What do these numbers mean? Like 192.168.1.100, and these numbers can differ. Okay, some networks can have 10.1.1.1. Something can have 172. These numbers they don't have a strict guideline, but they're just a number that I think there is a guideline, but it's no longer used. This is your IP address at home or in your office. It tells your computer where to send and receive data. That's all it does. Okay. So peek in the internet address book. So remember back in the day, we used to have an address book for like a notebook that we used to write our name and the phone number, right? So same thing. So your IP address is internet address, right? Your DNS, what it does is a name translator. Like if you were to think of it, google.com is just a server, okay? It has an IP address behind it. But if I were to tell you, hey, google.com is located at 45.63. I don't even know, but like instead of numbers, it's so hard for you to memorize it, right? But google.com is so easy for you to memorize it. But when you type in google.com, it has to go somewhere. So it needs to have a translator. When you type in, so let's say if Adhan is typing in google.com in the browser, okay, google.com is located at this address. It's just like a pointer, right? That is a thing called DNS, okay? It literally just translates name into IP address to its location. And this is done globally. So it's in the public network as well, okay? So when you type in google.com, it's going to an IP address. It's through the usage of DNS, okay? It's called. IPs can be reused privately or be globally unique. So internally, inside your home, it can be reused hundreds of thousands of times, no problem at all. Or it could be unique, globally unique. Like if you're using Rogers or Bell, right now you're getting a public IP that Rogers issues you. That is called public IP. Okay, they're all on DHCP. It's not static. The reasons because they don't assign it statically is same reason. If you don't if somebody doesn't pay their bill and they're getting off, they don't want to give it to them like permanently. Take that back. So every 30 days or every 60 days or every 90 days, it renews automatically. And if you wrote down your IP address today, your public IP address today, and look in like 2 months from now, it'll be a different IP address, or maybe even 30 days from now, it'll be different IP address. Okay, it's because of they just want to make sure that they're not issuing out a lot of IP address and not being used, right? So they just claw it back and assign as it needed. Okay, and we'll actually see how to actually get your public IP address. That's where your network is located. What's my IP address on the internet? Just like mail needs your home address, the internet needs your IP address. Every phone, laptop, printers has its own IP address. Okay, every node will need its own IP address. How do I get an IP address? Through DHCP. Gives out IP address automatically. Sometimes we assign them manually through static IP. You can find yours with IP config. In Mac, you can use IF config. Okay, it's called IF config. Let me just that's fine. Well, next class we'll do all the activity. Okay, that way it's easier for us. Network troubleshooting and Wi-Fi best practices. So in this agenda, we're going to be looking at introduction and objective, network troubleshooting basics, troubleshooting tools and techniques, real life scenario, Wi-Fi fundamentals, Wi-Fi best practice, and question and answer and wrap up. Okay, and this is going to be our last set of thing for today, and then we're going to next class is going to be 100% hands-on. Okay, we're just going to do some class activity and we're going to go into the slide. Okay, all right. So what is network troubleshooting? Definition: diagnosing and resolving issues that affects network connectivity and performance. Why it matters is ensures continuous access to resources like the internet, email, printers, and shared drives. Tier 1, which is you guys, will focus on basic checks, escalating complex issue. Okay, all you're doing is once you figure out it's not something you can handle in your side of things, you pass it on to the networking team. That's your role. But you need to still do the basic checks. You still need to check if this is something you can resolve on your side, right? Because you don't want to just keep on passing. As soon as it says networking issue, you don't want to keep on passing. As soon as it says like Windows Server issue, you don't want to keep on passing. When you pass, you need to put information in it and then pass it, right? That's part of your job, okay? And that's where a lot of tier 1 fail, or they don't last long in job, is they're not getting enough information to pass it on to the next team. And you need to justify yourself why you're passing and the reason for passing it, right? That is what's very important, okay? Type of network problem. It actually, to be honest, it falls under these 6 categories. Network problems only falls under 6 categories. No internet access, limited or no connectivity, slow connection speeds, dropped connections, IP address conflicts, DNS issue. These are the 6 categories, okay, that it falls under. There's nothing much more complex than this that you'll ever see. Troubleshooting process. And this is the 6th step that CompTIA A+ recommends, okay? And whenever you're answering in an interview as well, use these 6 steps to answer them. And this is what a lot of interview people like, especially in a level 1 area, because it creates a systematic troubleshooting methodology, okay? First is to identify the problem. Second is to gather information. 3 is to narrow down the cause. 4 is to test hypothesis. 5 is to fix and verify. 6 is to document and escalate if needed. And this is a 6-step process, okay? And I'll tell you what the thing is like. I'll just give you an example, okay? If somebody's calling you and be like, hey, I'm not able to connect to my network, right? The first thing you want to do is identify the problem, which the problem is they're not able to connect to the network. But you don't know, are they using cell phone? Are they using laptop? Are they using desktop? Are they using, smartwatch, right? You need to first identify what exactly the problem is. Not just like, oh, they're not able to connect to the network. You need to know what are they trying to connect with, and are they on Wi-Fi or are they on wired? You need to know all this information, right? That's what helps you to, get more information about the errors and try things. So when you're gathering the information is what's going to help you to narrow down the cause. So let's say they're using Wi-Fi at home, right? Which now change dynamic. Then I'm saying network is not working. It doesn't have any context behind it, right? The context. So let's say home Wi-Fi is not working. Some workplace, and I know most workplace, unless you're working for Rogers or Bell, home internet not working is not really something you will fix internally. That's not something yours to fix, right? So you tell them use your Wi-Fi hotspot to work, but the dynamic changes when they say I'm at workplace, my internet's not working, right? You'll ask them, okay, is it just you, or is everyone else in the area is not working, right? I'm saying, no, everybody else is working, just me. Now, then you test out some hypothesis, right? let's say you're saying that they're probably not signed into the Wi-Fi, or they're probably using an incorrect Wi-Fi, different Wi-Fi name or something like that. Then you test these hypotheses, right? Let's say you come to a place that they're connected to the wrong Wi-Fi address. You test it, you verified, and then you now document saying that this user was connected to a different Wi-Fi name. So I ran through the step, I documented it, and then you close the ticket. But let's say that they're not able to connect on the same Wi-Fi. Now it's not you, right, to go in the networking room and check what is from the networking switch side or networking router side. You collect all the information and pass it on to the networking team. And I'll show you guys. This is just why I'm not putting in a lot of details is you guys will not have context if I say it right now. So in the next class when we come in, we'll actually go through these again, and I'll show you guys what you need to do in from the command line way, okay? So you guys can get more information. Okay, 6 step. Just when you guys doing your watching recording, write these 6 steps down, because we're going to be talking about the 6 step on the last class as well when we do our troubleshooting methodology. These 6 steps are not just for networking; they're pretty much in anywhere in IT. You use them to do troubleshooting. Okay, this is the same process, and this process applies to anything you repair, electronics, fridge, because it's a basic troubleshooting methodology that's been created. Okay. Tools for troubleshooting. One is ping, P-I-N-G. ipconfig, or in Mac it's called ifconfig. You can use something called nslookup, trace route. In Mac I think it's in Windows it's trace RT, but in Mac I think it's actually trace route. And then there's something called networking and sharing center and task manager, and I'll explain what these does, each one of them. Ping is a basic level test. Okay, you're gonna do ping. Ping is something that you're gonna love. You're gonna love every day. The reason is because it tests just basic connection. I can check if me on this website, do we have connection? Or I can check if me and this computer, do we have connection? It's a basic check. If it fails, it means that it only gives you 10% information, or 10 or 50% information, okay? I would say 50% information. It's telling you I don't have connection. But it doesn't give you the context behind it. Where did it stop? How did it stop? Did it actually leave my computer, or it didn't even leave my computer? Did it leave my computer, and did it go through a router? And where did it stop, right? We don't have any context behind it. And for that, we can use something called trace RT, or trace route. What it tells us is, if it tells us each and every step the communication is taking. It's leaving my computer. It's touching my router. It's now going to the Rogers. It's now leaving Rogers, 2nd place, 3rd place. And then if you're in Bell, it goes to the Bell communication server, and you'll see it will just stop, because Bell and Rogers are 2 different families, right? So they don't want you to talk to 2 different families, so they'll stop. And it's beautiful to see when you're working trying to do this in a command line. You'll see clear-cut information on where it stops. But for you to, let's say that's a troubleshooting methodology, right? Now, if you want to check network resolutions and DNS, right? DNS information, you want to see, okay, if I type this name in, where does it point to? What servers does it point to? Sometimes, like our CTEC training center, we're not like a YouTube or something like that. YouTube has like 15 or 20 different IP addresses, because YouTube does not want you to go on youtube.com and be like, okay, the server is too full, right? They'll have 10, 20 different servers that, okay, one is busy, they'll send you another one. Whereas CTEC training center has only one DNS where we can send you to. But that's how it works, right? Like you can check where it is actually going to, where it's actually leading to. Next is called ipconfig, or ifconfig in Mac, okay? Mac and Linux. In Windows or Mac, when you type in the command, it shows you your computer, the IP address is receiving from your router, the subnet mask, and there's something called default gateway. And I believe in Mac and Linux, it's called the I believe broadcast ID. I'm not sure, but we'll figure it out when we go there. That's not a problem. But it shows these 3 information. Why the IP? It shows the IP address that's been assigned to your computer from the router. Next is a subnet mask, or the network you're in, actually. The third is default gateway. The default gateway is something that we never talked about, if you guys realize. We talked about subnet mask and we talked about IP address. Default gateway is just basically telling, if your computer, remember what we talked about, oh, I'm so sorry. Did I not share the screen? I'm so sorry, guys. I'm so sorry. I've been reading off the slides, but I'm so sorry, guys. So sorry. I was going through these slides over here. My apologies. So this is what I was going through, okay? So this is what I was going through. Sorry, I didn't see the screen until thing. So this is what the slides I was going through.
That's what I was confused. I thought it's
Sorry.
more of a theoretical.
I was too excited. Sorry.
So,
I should have checked the screen because I was just having something else on the screen and I was just looking through, and this is the information I was looking through. Okay. This is 6 information. This is what we just talked about right now. Okay. Okay. So the reason why what I was going to say is this one. I'm so sorry. So remember, your router stays in between here, right? And what I was gonna Windows IP config, and I was talking about IP config, and I was telling you, okay, so remember, your router sits in between, right? It knows your router is the only one that has a connection from the outside world to the inside world. Your internal, this band over here, this is where everything's restricted. It doesn't have connection to the outside world unless it uses a modem or router, okay? In this case, router or modem, whatever you have at home. Unless he uses bridge, it doesn't have communication. Your computer needs to know, okay, which direction or who do I have to communicate to leave my home? This green circle is your home, right? So which way do I go, or who do I need to contact to, go out of this home and come back in, right? And your default gateway tells it. It'll usually be your router's IP address. And just as a thing, I'll show you guys here. I'm going to open up CMD. And next class, don't worry, we'll go in depth into CMD. There's a training that you guys will do. So if we do IP config, it'll show you this information. So I'll just zoom in here. You guys can see. Okay. So if you see, this is my IP address. This is what my router gave me. Okay. This is a subnet mask. Remember, I told you 255.255.255.0, which means in my home right now, I can maximum connect up to 254 devices. Okay. Until I need to create another network. And then I can create another network, okay? But this network can only handle 254 devices. I don't need anything more than that. I'm living in a normal order in a home, okay? If I have more than 254 devices, then there's something wrong with me. But this can do 254. Now, this default gateway, which what tells my computer, this is who I need to contact if I want to leave this home. It's a tunnel to the outside. If I don't have this defined, I can talk to the computer inside my network. So this is inside my network over here, right? So these guys, I can still talk to them without talking to the default gateway, which is a router or the modem. Okay, I have still communication with the 20 or 30 different devices in my home, but I cannot leave my home. Okay, does that make sense, guys? That is why a default gateway is very important. Okay. And Task Manager, there's actually in the pre-recorded video, there's one of those videos I go over Task Manager to show you all the networking and how to actually open that up to see resources and to check if the computer is slow, the reasons why it's slow. Okay, there's a Task Manager. And next class we will briefly go over it too from the pre-recorded video. I'll go and quickly share through it too, so we'll walk through the steps again. Okay. Physical check first. Remember, OSI model 2, there's 7 layers, but the first, it starts out with a physical check, right? So whenever any type of troubleshooting, whatever it is, check the physicals thing. And guys, and one of the things that I always, the mistakes I have done in the young age, and I've always seen younger people who's coming into this, what they do is they assume. Okay, they think. Don't think, always check. Okay, and I'll tell you a story. I'll tell you a story. Is when I was young and when I went to work at Algonquin power plant. This was a big corporation, when I was young, very young. When I went to work there, I had 2 years of experience when I went to work there. So I thought, arrogant, that thought I know everything. So I was not a senior, but I was not a team lead, but I was in between. I was not a junior, but I was not a senior. I was in between, right? So when I went to work there, they had a conference that for Algonquin power plant. A lot of people from outside coming in to do conference for this whole thing, and it was like a 300 personnel theater that they have inside. And they told me, hey, Athavan, there's the speaker system is not working. The speaker mic system is not working. Can you go and take a look at it? Because they thought I had experience, which I thought I did too. So I go in and I check it out, and I go in the computer. I check the drivers. Everything seems fine. I check, I check the software of it, everything. seems to be fine, but speakers still not working. The mic is not working at all. I tried to, restart the computer, still does not work. And I was like, okay, I thought it's probably a software thing. I was like, okay, let's reboot, reinstall the computer. So I reinstalled the computers, still did not work. And then what I did was, okay, let's say maybe it's a computer issue, right? And this is 6 hours, 3-4 hours, and then 6 hours, it's going by, because reinstalling a computer back then on a hard disk, it takes around 2 hours to do all the updates and install all the software. It takes around 2-3 hours. So it took about 4 hours. And then I replaced the computer because I thought it's a defective computer. I replaced the computer, still did not work, and I tried to install it. This is now 8 hours. This is been 8 hours. And so, and when you're doing full-time work, or when you're doing salary work, you don't get overtime. So I was like, okay, I go home slightly late. I think I did like some overtime, 2-3 hours. They don't pay you extra, but I just want to get it done because it's my prestige now, right? Now it's my ego is touching me. So I was like, okay, you know what? I got so frustrated. I go out and I come back the next day, and I was just like, they're like asking me, okay, so in like 2 days there's going to be a conference. So I hope the thing is working. I was like, yeah, you know what? It's not working. I think maybe the whole system is just busted, right? And the senior technician comes in. So he's this guy. He's a team lead, and he comes in. He's like, oh, did you power on the speaker? And I was like, yeah, I'm sure it's powered on. Speaker system need no power. He's like, you sure? Or did you check? And I was like, yeah, I'm sure. Right? He goes in, turns on the switch, boom, 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 all the speakers just start working. So I spent 12 hours without checking the single power switch on, I did everything except for touching this power switch for the speaker itself. So that's why physical check always matters, and never ever assume. I assumed that it was working, and it was a very insulting thing for me, but I learned my lesson then. I don't ever think that, even if tells me it works, I have to check to make sure, right? So, and you be the same thing too. You have to check physically for you to think that it's working. Okay, it just feel like I have to check. Don't assume from it, right? So, check the cables and power first. Restart the modem and router. Now, at home, you can restart your modem and router. At workplace, you cannot go and be like, I'm going to restart the modem, because remember, 3,000 people are working. You can't go ahead and shut down the router or switch like that, right? There's actually a planning behind it. There's actually a team that does this. It's called a CAD, a change management team. Okay, they actually do the change management, and if they want to reboot, they'll properly plan it, let everyone know, and properly plan it. Okay, but the rebooting computer, you'll be surprised of issues coming in with the user's computer. The first thing you do is reboot the computer. It fixes about 70% of the issue. 60-70% of the issue gets fixed by rebooting computers. Mac is slightly different, okay? Mac is slightly different, but on Windows computer, 60-70% of the time, rebooting computer fixes the issue. Make sure Wi-Fi is turned on. A lot of times, there's a switch on the laptops that on the side, it's turned off, or the Mac, not Mac, on the Windows laptop or now new laptop, they actually have a shuttle on the camera, webcam. It'll be slight, it'll be turned off, so they won't be able to see them, right? So small things, and trust me, I've seen them so many times. How many times they have shut off their, like, I'll show you right now here. If I were to switch this camera to integrated webcam, let me see. Yeah, see here, it's my other one. If I were to shut down like this, they'll be like, my camera's not working. But there's actually a shutter that makes this to work, So always check to let them know that if the camera's working, it's a shutter, turn it on and turn it off, right? So it's those things, the simple things that actually fixes a lot of issue. Check for loose or unplugged connections. The reason why I say loose or unplugged connection is a lot of times when they tell the desktop computer is not able to connect to internet, and you assume that it's connected through the cable, which you can ask them to check the back of the desktop and see if the cable is plugged in, right? Blue or yellow cable, Ethernet cable. So yeah, it's plugged in. Tell them to remove it and plug it back in. Because sometimes, when we work in a desk, right? When we lean back and kick back our leg, sometimes we hit the cable and the cable will become, slightly out of the computer. So pushing it back in or taking out, pushing it back in will fix the issue. And I've seen that like hundreds of times. Like, when I used to work in hospitals, like hundreds of times, like in a per day, if you get like per day, we used to get 300 calls. That's normal in IT, okay? IT 300 calls in the front desk is normal. It's very normal. Out of 300, at least 75 of them are these cables being, pulled out. That's it. 75. That's, if you think about it, that's around 25% ratio. On a bad day in a hospital, you get 1,000, 2,000 calls. So that on a bad day, but on a good day, 300 calls is very normal. And ticketing wise, we always have 600, 700 tickets actively in the ticketing system. And I'll explain that just slightly down the course. Any questions so far, guys? No? Okay. Okay, so these ones we'll actually work on them next week, because these ones we have to go through the task activity, and then we'll go through the scenario, because these ones will definitely will have to go something. So, I mean, that's all we have for today, to be honest. Any questions so far?
Not for now, sir. So
Very good.
today for the basic thing, I'll just relearn everything. Like it's
Yeah.
just basic, I know, but I think the major thing would be next week, right?
Yeah, we're doing next week. So once I think I don't think you missed a lot, Govinder. I don't think you missed a lot, to be honest. You only missed like maybe 5 minutes, which was just introduction. So nothing too much. So all the course, once it's done, it'll be uploaded to LMS, and I'll send you guys an email. Go in the week 1 below the the green recording live recording. I'll just show you what I mean by that. Is here. When you guys log into your thing, just go into your course, and you guys will see in here, just underneath this recorded live, you'll see it here, okay? The video for today's. And as soon as I put it there, I'll send you guys all an email, okay? And all communication throughout this class will be from me from email, okay, itself, with the title of ITHD-MAR26, okay?
Okay.
Perfect. Thank you so much.
I just want to ask, ticketing basically means documentation of something, some sort of issue.
Yes, exactly. So we want to monitor. So the reason why is we want to have a place where not just document anything new coming in, right? If somebody tells you, hey, I can't log into my Windows computer, or I need this, I'm not able to access this, they're all the ticketing system. Either you will put them in, or the users can actually put them in as well. But this is where you go in to collect your work, to do your work. Almost, I would say, 70% of your workload will come from there. In a typical organization, okay? The reason why I want to say 70% is there'll be 20% of this is what when I used to be operation manager, okay? The reason why 70%, there 20% is going to be a project. So every year, IT, when I used to be in hospital, we used to have at least 60-70 projects a year, and they're like minimum of $30 million worth of projects, right? So deploying new computers, new printers, there's 50-60 projects. You might be a small part in a project, or multiple projects. So the 20% of your timing will be allocated for that, right? And then now 10% is for, maybe I always say like the 10% is for your personal growth. So I would give you time to do certifications, maybe 1 or 2 hours per week to do your certification studies, right? So that's for my team improvements, right? So but it gets different teams, like different managers like doing a different way. But typically on a normal company base, you'll look 70 to 80% of your work will come from a ticketing system. Maybe 20 to 30%, somebody will come and tell you, hey, can you do this work? Can you do that work, right? That type of work, But you can actually communicate with your team lead and ask them, is all my workload going to be on ticketing system? Or is there going to be some going to be in ticketing system and some going to be assigned to me, And which is a very good approach for you to ask, because some companies are very strict. They're like, no, it has to be ticketing system. So we can monitor what you're doing, and we can do, your promotions, your hikes, and your salary hikes comes from there, right? Depending on how long you take to do work. A lot of if you look at like a lot of big corporations, IBM, Lenovo, Microsoft, these guys, everything's through ticketing system. Even somebody wants to give you work, it has to be the ticketing system. So
Okay, got it. Thank you.
no problem at all. All right, I hope everybody enjoyed their class today, and I hope I made it simple for you guys to understand a lot of these concepts. And next week, we're going to go over a little bit more hands-on. And obviously, I know one person has Mac, which is good. Then we'll show you some commands for Mac as well. Same commands, how you can run on Mac. And as long as you as long as you run on Mac, it's pretty same concept on Windows as well. It doesn't change the fact, okay? It is the command will slightly change from Windows to Mac, but the way how you run it is the exact same, okay? It doesn't change the fact. Okay. All right, guys, team, thank you so much for joining in today on time. And next week, also, we have a class. Oh, go ahead. Ali, you have a question?
And I just want to say thank you.
Oh, no problem. No problem. Yeah, so next week, same time, 6 o'clock. Usually I leave around 5 minutes for everyone to join in, and we'll go through, next class will be a very fun class for you guys. Okay. Thank you so much, guys. Thank you. Thank you.
Alright, sir. Thank you so much.
Thank you. Thank you. Please, before next class, when you guys join, please watch week 1 and week 2 record a video. And if I was going to ask you to sign up for anything, I'll tell you guys, don't sign up for things I don't sell you, because some of them do have a timer, okay? You'll be charged afterwards. So that's the reason why, okay, I want to be careful on. But everything is there, but just watch week 1 and 2. If you want to watch everything else, go ahead, watch it. Not a problem at all. But just don't do the activities, okay? Because they're actually, some of them are timed, because Microsoft actually charges for certain things after a certain date. That's the reason, okay? I'll give you all the proper warning so you guys don't fall in the trap. Okay. Thank you, guys. Thank you very much. Have a wonderful weekend, and I'll see you all next week, Saturday at 6 p.m. Okay? Thank you.